I'm going to sort of start catching up to you guys here. So this is what you should have gotten for the first part. The median was 13. The median, I put them in order down here. So what you can do if it's a small set of data, you just kind of count your way in. Bam, 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 bam. There's 2 in the middle, so I just average those and I get 15 for the median. The mode, 16 wins. It shows up 3 times more than anybody else. I know that 4 shows up twice, but 16 won. Nah. Range, 20 minus 4, high minus low. Mid-range, add the high and the low, divide by 2 12s in the middle of the range. So all these are different measures of center, and they all come out a little different. Of course. That's the idea. So how are we doing there? Any questions on that first part? Now here it's just really a matter of counting how many times something shows up in each class. So there's 2 things between 2 and 5. Between 6 and 9, there's 1. Between 10 and 13, there's 2. 14 and 17, there's 1, 2, 3, 4. 18 to 21, there's 1, 2, 3. And to be honest, I teach a stats course too, so I can't remember. Did we actually create histograms in here a while back? Yeah, we did. Okay. So, that would look, it would be 1, 2, 3, 4. So it would be 2, 1, where are you at? 2, 4, 3. Alright, so it would look like that. It'd be, yeah. Can't remember how in-depth I got with you guys. This should technically be 1.5, 5.5, 9.5, 13.5, 17.5, and 21.5. The little, you go up and down by a half so that they don't have any gaps in between. So does that look, did we talk about normal? Does that look normal? Normal curve looks like this. That does not look normal because it starts off kind of high and then goes low and then it sort of looks a little normal here, but it doesn't look normal. Wah!
I don't know if we discussed normal.
Okay. The bell curve, just to throw that in there. No worries. So you can get lost in the details down here. This is just to give a quick visual of the data. You guys have seen these kind of graphs all over the place. It's just a quick visualization of the data. This is a little more technical, and it's easy to get lost in this, but can somebody tell me standard deviation measures what?
How far away from the middle are you?
Yeah, the spread. How far from the middle you are. So if I had another picture that looked like this, don't worry, I'm going to get it. Which one would have a bigger standard deviation? Oh, it looks like it's flipping you off. This one or this one has a bigger standard deviation. Which one? The original one or the new one has a bigger standard deviation? The original, because it's more... The original because it's more spread out. I like it. The standard deviation is a measure of the spread of the data. I like it. This one, leave us alone. Stop doing that. All right, now here, the reason I put, you don't have to have this in order. Somebody's asking me. You don't have to, but it just makes it quicker to see the repeats. This is going to be -9 again, 81. 7 minus 13, -6 squared is 36. And again, when you square, the negatives should go away. 10 minus 13, negative 3. Squared is 9. This is going to be negative 1, 1. This will be 1, 1. This will be 3, 9, 3, 9, 3, 9, 5, 25, 6, 36, 7, 29. And then when you add all this stuff up, what do you guys get? Because remember, that's what this symbol means here, right? That's the Greek letter S. Math people went, let's use Greek to make it look all official. So that's the sum of all this. And what do you guys get, sir?
346.
346, cool. Almost 350.
350.
So when you sum those up, so this whole symbol, this is the new thing. This is where algebra students have a lot of trouble. Because this whole thing is the entire thing is 346. So the whole top is 346. You can't plug stuff into there because that's all these individual things. I need the sum of all that stuff up on the top. And what was n? What does n mean again? Total number. And I had 12. Sorry. Yeah, I had 12 of them, right? So 12 data points minus 1. 11. And then 346 divided by 11.
45 repeat. 31.45 repeat.
31. I'm sure 31.
Is that sure?
I mean, yeah, I mean,
3, 33, 16. Yeah, 31.45.
I'm not lying.
Jeff was having a moment. So that's this guy. Well, you know, trust me. People trust their calculators too much because sometimes they put stuff in there wrong. But that was me. So that, I don't know if you guys remember the name of this here. Nope. S is standard deviation. So what do we have to do to get to S? What do we have to do? Take a square root. Because this is S squared. I want S. So if I take a square root of both sides, it should be 5 point something or other.
5.6084.
This one, the S squared, is called the variance. This, of course, is the standard deviation. So on average, the data points get that far away from 13. They get that far away from the mean. That's the average distance they get. So that seems like a really good number to know. If I know where the middle is, the mean, and I know how far away the data points get on average, I have a good little feel for what it looks like. That's why those two numbers are the most used numbers to summarize data. Now I have another part to this question, of course. What percentage of the grades are within one standard deviation of the mean? All right, what was the mean? 13. Within one standard deviation. So if I said, guess my weight within 5 pounds, what does that mean? I would allow you to be 5 up or 5 down. So within one standard deviation means go up one standard deviation and go down one standard deviation. So that's what the word within means. So if I add one standard deviation to 13, where do I end up?
18.
Yeah, 18.608. And if I subtract,
So 13 plus the
7.392. You guys see that? So all I did was add one step and subtract one standard deviation, right? I call them steps. Let me see if you guys get this. It's not that big of a thing. It really isn't. How many data points do I catch if this is how wide my net is? Do I catch the 4s in between here? No, of course not, because they're below 7.3. Do I catch the 7? You sure? 7's in here? Isn't 7 below 7.392? Yes. So I catch from 10 up to what? Up to 18. I catch how many? 1, 2, 3, 4, 5, 6, 7. I I catch 7 data points in there. 7 out of how many total? So what percentage is in here? 7 out of 12. That's 0.583, so 58.3 for every percent. Double check me. I'm having a rough brain morning. Does that make sense?
Yes.
How much do I catch? Well, first you got to see how wide's your net. And then you go see how many you caught out of the total. That's the percentage you caught. Like it. Now this, if any of you taken statistics, this idea we just did, there's a lot of theorems about this. If you have a distribution you don't know anything about, you can still have theories about how to figure out what percentage is within 1 step, 2 steps, 3 steps. This idea of what percentage of the data is in here is important because, for example, how many guys have flown in an airplane? How many guys have ever been bumped? Anybody? You're bumped. You guys know what a bump means? Some of you guys are like, oh, I love you. And they're like, what's bump mean? Some of us know all too well what bump means. And in fact, you should know really, really well what it means because somebody got bumped excessively hard, and that was a viral video. I love that look on them. Somebody's like, what are you talking about? I got beat the shit up and taken off the plane? Okay. So bump normally means you don't get let on the plane. They offer you money in exchange. So why does that happen?
Because they've overestimated, they overfilled the flight.
Exactly. They overfilled the flight.
Yep.
Now why do they do that? That seems like a dorky thing to do.
Because they're waiting for last minute people to not show up.
It's all about...
There's a certain amount of people in a flight that don't show up. So it's like if they know that, or they figure that 6% of the total passengers won't show up, they overbook by 6%.
So this idea, they got... If there's so much in here, they got a chance that some people won't show up. They know the probability that somebody won't show up. So they can construct kind of like the safe area to overbook using an idea similar to this. They can try to overbook and what they can, because they want the plane as full as possible because they want to get as much money. That plane's going to go up in the air no matter what the ship. They want to get as much money for that flight because it's going to go, right? So in the business sense, it makes sense. But this is the kind of thing that leads to the stats that they use to figure out the appropriate level, the appropriate probability of having to bump somebody. Because that's kind of like control between making money and then bad PR.
Yeah.
Right? And obviously they really had some bad PR recently. I always do Southwest, so they're pretty nice. Alright, so let me do this. This is the one that other stuff to practice for the final other practice. I'm going to have the answer for this probably Thursday. What's up?
So we do have to put it up.
Yes. Some of you guys are going to love it. By the way, guys, be real careful about that. I'm not going to give anybody any extra time. Don't be crying at me. I got to be here freaking before. So you're in that seat, then you're willingly giving up time for the final. I'm not giving any extra time. Okay.
Oops, sorry.
What's x to the 9th divided by x to the 4th? Yes, good. Now do the same thing you just did to that. What did you just do?
What I do?
What did you do to get x to the 5th? You did 9 minus 4. You subtracted the exponents.
Right.
Alright, so you got 3, what is it?
3, yeah. So
We're all trying to get out.
So what's 3m minus m?
Too much.
So 3 to the 2m.
Oh.
Yeah, the answer here is not 5.
Well, no. You're right.
Do the x's cancel? Of course not. You have 9 x's, take away 4, because this is built on multiplication, so I'm going to have 5 x's left. I have this many 3's, this many 3's, I have this many 3's left.
Right.
The base doesn't do anything. Really? So what's 3 cubed over 3? That's not 1,
Right.
because it's 3 times 3 times 3 over 3, so how many 3's do I have left? 2, so that the base doesn't
Because
change.
that changes everything.
Yeah, I change how many of these I have left. I do nothing with the base itself,
Right.
because it's just this thing repeated a bunch of times. So I just want to know how many of these are left.
Right.
Cool.
Okay.
Cool.
So, is this similar to what happened last time with Link? Because I apologize for missing that quiz. I all for it today.
Yeah.
Yeah, I wondered because I was like, it's lighter than usual. And then
So you can see what it looked like, and basically, since the only thing we have left is
the
the
final.
final, that's going to count in place of this missing glitch.
Okay. Yeah. Can I take this with me?
Yeah, of course.
Awesome. Thank you so much.
Sure.
So we do have class all this week, but not next Tuesday, Wednesday.
Yeah, this is the last week of normal class time for
Alright.
everybody. Yeah.
Okay.
Yeah. Oh yeah, what's that equal? What's log base m of n? No.
No.
What's log base 4 of 4?
1.
Alright, so what's log base m of n? 1.
Okay.
Yeah.
Right. Can I give it to you now?
Oh yeah. Man.
All right. See you then.
Okay.